A magnet invention first conceived at the University of Minnesota is making headlines tonight after being ranked one of the best of the year by Time magazine. This is what powers your world without you knowing. Not oil, not sunlight, not even electricity, but something quieter, invisible, inescapable. Magnets. It's a material that has zero electrical resistance. So that means it can carry current without generating any heat. They're in your headphones, your phone, your fridge, even your car's motor. If you erased them from existence, everything would stop. Magnet is everywhere. Yeah, I moved here as associate professor and it means they trust me try to work on something new. Now imagine magnets 10 times stronger than anything we've ever made. That's what one company claims to have built. And with them, a new breed of impossible machines might finally come alive. The plan is to be able to produce iron nitride bonded magnets. These would be alternative to the bonded neomagnets that are on the market today. Devices that once defied logic, denied funding, dismissed by science. This is the story of supermagnets and the silent war to rewrite the rules of energy. Magnets, the invisible backbone of civilization. You rarely see them. You never hear them. But they're always there, spinning, holding, pulling, pushing. Magnets are the quiet force that makes modern life possible. Every time you swipe a card, drive a car, charge a phone, or watch a video, magnets are silently working behind the scenes. They're hidden inside hard drives, hospital machines, speakers, and satellites. They generate electricity in wind turbines. They power the motors in electric cars. Without them, the world would flicker and stop. But for all their importance, magnets have limits. Even the strongest rare earth versions made with exotic elements like neodymium eventually lose their edge. Heat, time, and structural fatigue wear them down. Their magnetic fields, while powerful, are still finite. That's where the bottleneck begins. Because the next frontier of technology, especially energy, is waiting on better magnets. The ones we have now can't push us past the barrier. They've hit their ceiling. And for decades, that's where revolutionary ideas have died. Free energy machines, perpetual motors, magnetic propulsion, all fascinating, all flawed. Not because the inventors were wrong, but because the magnets weren't strong enough. Now something's changed. A new kind of magnet is emerging, and it might just unlock everything that was once thought impossible. Niren magnetics, the quiet revolution begins. In a small lab at the University of Minnesota, a breakthrough began, not with noise or hype, but with patience. It wasn't a new motor or energy source. It was something far simpler and far more powerful. A magnet. But not just any magnet. This one didn't rely on expensive rare earths. It wasn't mined from distant corners of the earth or tied to fragile global supply chains. It was engineered, built atom by atom with a new kind of precision. The company behind it, Niren Magnetics. While giants of the tech world chase electric dreams and hydrogen highways, Niren has been quietly redefining the one thing all of them depend on, magnetic force. Their new class of magnets, based on a proprietary alloy of iron and nitrogen, produces magnetic fields up to 10 times stronger than conventional rare earth magnets. It's not just the material that's different, it's the process. Through a fusion of advanced metallurgy and nanoscale engineering, Niren can pack more magnetic domains into less space, creating dense, stable magnets that are lighter, stronger, and more efficient. Suddenly, machines that once struggled to turn might never stop spinning. And for a handful of forgotten energy inventions, Niren's breakthrough could be the missing piece they were always waiting for. Now, first, like always, be sure to hit the like button down below. It helps us out tremendously with the reach of this video. Thank you. The phrase free energy has long lived in the shadows of science. To some, it's a scam. To others, it's salvation. But before it became a buzzword, it was a question that's haunted inventors for centuries. What if machines could run forever? From medieval spinning wheels to Victorian perpetual motion sketches, the obsession never died. In the 20th century, it surged again. Men like John Keeley, Joseph Newman and Howard Johnson chased the same vision, extracting usable energy from magnetic fields, inertia, or subtle forces we don't fully understand. Their machines turned, some sparked, a few even lit bulbs. But none could escape the same fate: ridicule, rejection, and obscurity. Not because the ideas were flawed, but because the magnets they depended on simply weren't up to the task. They needed force, stability, and endurance. And traditional magnets couldn't deliver. So the motors sat in garages. The blueprints gathered dust. The promise was buried. But now the magnetic game has changed. What happens when you revisit those forgotten machines with super magnets 10 times stronger than anything they were built for? What happens when yesterday's limitations are removed? The dream isn't gone. It's just been waiting for better tools. What if it finally worked? In the 1980s, a man named Joseph Newman made headlines with a strange motor. Big, loud, and spinning with a sort of hypnotic rhythm, it seemed to generate more energy than it consumed. Newman swore it was real. The motor used a combination of high-voltage coils and powerful permanent magnets to produce mechanical motion with astonishing efficiency. He took it to court. He built it live on TV. He begged for recognition. But again and again, scientists dismissed it. The math didn't add up. The motor violated the sacred first law of thermodynamics. And perhaps it did. But what if it didn't? The one thing everyone agreed on: Newman's magnets weren't strong enough. Not nearly. Now picture that same motor rebuilt with Niren super magnets, a smaller, lighter frame, 10 times the magnetic force, greater rotational speed, higher torque, less energy lost to friction or decay. What once barely spun might now roar to life. Could a redesigned Newman motor finally cross the line between curiosity and utility? Could it produce enough power to sustain itself and more? With the right magnet, what once looked like a physics error might just become an energy breakthrough. And suddenly, Newman doesn't look so crazy. Howard Johnson wasn't trying to make headlines. He was trying to make history. In the 1970s, he built something almost too simple to believe: a motor that spun using only permanent magnets. No wires, no fuel, no battery. Just magnetism, carefully arranged to repel and attract in sequence. He called it the magnetic propulsion system. The idea was to position magnets in such a way that the rotor would always find a new push, an endless path of motion with no input. It worked, kind of. Johnson's prototypes could rotate, but the force was weak. Friction, alignment issues, and magnet degradation kept it from scaling. The theory was elegant. The execution fell short. But what if it didn't have to? Enter Niren's magnets: dense, precise, insanely strong. By upgrading Johnson's design with modern super magnets, the torque could increase dramatically. Each repelling force could be magnified. Rotational speed could climb. And most critically, the machine might finally overcome internal resistance. Johnson's dream was never disproven. It was just out of reach. Now it may not be. His blueprints still exist. His design still inspires. And with better magnets, his motion-only motor might finally do what he always believed it could: run freely forever. John Bedini wasn't out to break the laws of physics. He just wanted to recharge a battery with another battery without losing energy. What he built instead became one of the most discussed free energy devices of the 1980s. The Bedini motor ran on pulses, electrical bursts delivered to a spinning wheel of magnets. The idea was to create a flywheel effect where each pulse added energy without significant drain. His circuit was simple. The results were puzzling. Batteries lasted longer than expected. The system appeared to loop energy. It wasn't perpetual motion, but it was efficient, uncannily so. Still, the limits were clear. The magnets weren't strong enough. The wheel couldn't sustain higher speeds. The torque wasn't there. With Niren super magnets, everything changes. A stronger magnetic field means a greater reaction to each pulse, faster spin-up, more kinetic energy, reduced friction losses. The same voltage could now deliver exponential motion. Bedini's circuit, already efficient, could evolve into something far more powerful, something scalable. For years, his work was studied, modified, replicated, and dismissed. But the physics didn't fail. The components did. Now we have new components. And Bedini's humble pulse motor might become the battery-saving, energy-recycling breakthrough he always said it could be. Among the strangest inventions in energy law is the Searle effect generator. It doesn't hum, it levitates. Invented by John Searle in the 1950s, it was said to use a series of spinning magnetized rollers arranged around a central ring. As the rollers turned, an electric current was reportedly generated along with gravitational anomalies. Witnesses claimed the machine would lift itself off the ground. Wild, yes, but completely dismissed? Not quite. The problem wasn't the concept. It was the materials. Stability was a nightmare. The magnets degraded. Rotation wobbled. The effect, if real, couldn't be replicated at scale. But now, what if you built it again? Niren's magnets offer stability at high speeds, consistent field strength, and perfect structural alignment. That's the missing piece in the Searle puzzle. With stronger, more durable components, the generator might finally be tested under real conditions. No tricks, no legends, just data. The Searle effect generator isn't just about energy. It's about the boundary between science and science fiction, a machine that floats, that powers itself, that rewrites gravity. Most scoff, some still believe. But one thing is certain, we've never had the magnets to try it properly. Now maybe we do. If you've ever played with two magnets and felt them push each other away, you've touched the core idea behind the Magna Coaster. Imagine a ring of magnets carefully arranged so their fields interact to produce constant rotation. That's the principle behind this mysterious device: no wires, no fuel, just magnetic interaction turned into torque. But the problem was always consistency. Once set in motion, the device could spin, but not for long. Drag, imbalance, and weak magnetic fields killed momentum. It was a novelty, not a generator. Until now. With supermagnets from Niren, the entire concept is reborn. Their field strength isn't just greater, it's cleaner, more focused. With proper calibration, the magnetic push can be sustained longer with less decay. This means the Magna Coaster could finally operate with enough torque to turn a generator, enough speed to charge a capacitor, enough power to matter. Even small gains here could change the game. Imagine a magnet-powered wheel that never stops, that turns a gear that powers a light that powers a home. Perpetual motion? Maybe not. But persistent, near-frictionless energy output, that's no longer fantasy. That's physics finally given the force it's always needed. The phrase free energy still makes physicists roll their eyes. And fair enough, many of these machines have failed spectacularly. Fraud, fantasy, mismeasurement. It's all happened. But the science isn't static. And neither are the tools. Niren's magnets don't violate the laws of physics. They obey them with more intensity. They allow machines to do what they were always meant to do, better, longer, cleaner. That's not pseudoscience. That's engineering catching up to imagination. Still, skepticism matters. Every claim must be tested. Every output measured. Every anomaly explained. But now we have a real chance to do that. And it opens the door to deeper questions. What if our models of energy production are incomplete? What if magnetism holds untapped layers of force we haven't fully explored? Science doesn't advance by rejecting the strange. It advances by investigating it. And that's where we stand, on the edge of two worlds. One ruled by convention, one lit by possibility. For decades, these machines were ahead of their time. Now maybe time is catching up, and with it, a chance to re-evaluate everything we thought we knew about motion, power, and what's truly possible. This isn't just about machines or magnets. It's about the future, and who shapes it. For years, these devices were dismissed as dead ends. Their inventors were called dreamers, cranks, or worse. But many weren't wrong. They were just early, too early. Now, with Niren Magnetics leading a material science revolution, those early designs deserve a second look, maybe even a second life. But progress won't come from one lab or one company. It will come from you, engineers, coders, physicists, students, the generation raised on renewable goals and climate deadlines. With supermagnets as your toolkit, what could you build? A wheel that powers a bike indefinitely? A magnet-powered water pump for remote villages? A gridless home? The possibilities aren't fiction. They're just unexplored. But it won't be easy. You'll face resistance, technical, institutional, even political. You'll need data, courage, and endless curiosity. But you'll also have something previous inventors never had, the strongest magnets in history. The tools to finally finish what they started. This is your era, and the machines are waiting. This is how the future spins into existence, not with explosions or fanfare, but with silence, with magnets, with motion, with questions. The kind that challenge everything we thought we knew about energy and possibility. The kind that spark revolutions in garages, not boardrooms. Niren supermagnets may not give us free energy overnight, but they give us the power to ask again, to try again, and maybe, to succeed. What happens next is up to you. The future doesn't arrive fully formed. It's built one idea at a time, one spin at a time. And it all starts with a magnet.